Welcome again to the NPTEL course on storage systems. Today we will look at one widely used storage medium/storage system. Okay, what is that one? That is the USB mass storage device. Okay, we'll just go through it a bit. It has got a lot of interesting aspects, and many of these aspects are there in any other storage system typically also. If you look at it carefully, you will find similar aspects. That's why it's interesting to look at it. So, I'm pretty sure that most of you have used it, right? It's widely available, and it came out first about 2000. Now, when it first came out, 64 megabyte was considered big, 32 megabytes considered big. Now it is close to 64 gigabytes you can get. Okay, somebody actually is somebody has come with a 1 terabyte USB stick. Okay, so it is the progress in this when it comes to density has been phenomenal. And what is the technology that is fueling it? It is something called flash storage. Okay, flash storage is a type of storage which is persistent type of memory. It is similar to semiconductor memory, but it has got some differences. We will not go into details about those things because it's not part of our discussion here. Okay, so it is essentially semiconductor storage. Essentially, there is some kind of a potential will that is created and you trap some electrons. Okay, whether electrons are there or not, that basically is a 0 or 1. Okay, and because it is an electronic technology, it does not have mechanical components. Okay, so some of the issues that are there with the disks are not there, but in spite of that, it turns out the electromechanical technology is still, in terms of density, much better than what we can do with flash. Okay, for example, you might have seen that 4 terabyte hard disks are available, 3 terabytes are easily available, 4 terabyte you can, if you spend some effort, you will find it. But getting this flash at that the same price point is still not easy. Okay, flash is about a factor of 10 times costlier than disk. Okay, so anyway, so it turns out this USB there is a based on the flash kind of semiconductor technology, you can build a mass storage device using USB protocol. What is USB protocol? It is basically a way of connecting some functionality in the form of some device to some system. It could be a PC, it could be a laptop, it could be a camera, it could be a printer, etc. Right? There are so many types of technologies. This basically a USB protocol is a way of having an electrical connection, on top of it a communication, let us say, protocol on top of it, so that some of the transfers that are required for the device to operate with the camera or the PC can be made possible. Okay, let us quickly look at what is there in the systems. USB has a microcontroller that handles USB protocol. Okay, again we will go a bit into more detail, but it handles USB protocol. A media controller that handles device specific part, example storage. As I told you, there could be different kinds of USB devices. One could be doing storage, one could be doing Wi-Fi also, right? One could be doing a printer also. So, there is a part which is connected to the USB protocol, a part which is connected to the device part of it. For example, the storage will be its own, for example, it has something called SCSI commands, SCSI, SCSI. Okay. Now, that is specific to a storage device, but it is not for a Wi-Fi device, that is not necessary. Okay. That is something different, right. So, if you are talking about a USB mass storage device, what are we doing right now? We are basically, we take the device and insert it into a laptop or a PC. The question is what happens? Okay. We will try to take a look at this one. First of all, you should be able to detect and respond to generic USB requests and other events in the bus, because something on the bus, because it's an electrical system, I put it in, and then there is an interrupt generated, okay, it is because of electrical connection, okay. And basically once that happens, then I need to know, I need to tell the device, now put your information on the bus, I want to know who you are, okay. So request identify attached devices, and this information is in the device itself, usually in a non-volatile part of the device, so that it does not have to be lost anytime you remove the power, okay. And also there are some specific things with respect to traffic, means whether the data should be going from this side to that side, from the PC side to the USB or USB side to the PC, etc. And also the powering the bus. I think all of you know that the USB device, the storage device here, does not have power of its own, okay. It has to be powered by the PC, it goes to the socket, the USB socket, and that power is given to it, right. And there are, this powering the bus also happens to that, let us say, there is a specific aspect of how to power it also. So detect and respond to USB mass storage request. One is the generic USB request, this one is the USB mass storage request, okay, such as status or actions on the device. For example, I might want to know, please, are you ready, for example, okay, things of that kind, okay. So for example, it may be that I need some information about the status of some previous action, things of that kind. And since it is a USB mass storage, it turns out they decided to use something called SCSI commands. We will go a bit into it later, but basically SCSI commands are a way of interacting with storage devices. It has become the most popular protocol for interacting with storage devices, okay. And these SCSI commands are things like read from a particular block, write from a particular, write to a particular block, okay. And it could even things like retry the previous request because I couldn't, you send me something but I can't make sense of it, okay. Keep the information about your previous, whatever happened last time, I want to know the status of that one, things of that kind. This SCSI protocol has commands of that kind, okay. And such as read and write blocks of data in the storage media, request status, information, control device operation, okay. And these at the SCSI level. There is also one more thing at the file system level, okay. For example, you notice that most of the USB devices are formatted to something called FAT32 file system, okay. That means it has got a particular notion of how the let us say the file system metadata, where is it kept, okay. So and then since you know where the file system is, metadata is there, you can do what is called a mounting the device, so that it is accessible as a file system. What does it mean to say that the device is accessible as a file system? In a Unix kind of system, this particular device now is in the namespace of the Unix system. For example, I might have it as /dev USB on a Linux system, okay, and then I can cd to that /dev/USB or whatever /dev/whatever, okay, and I can change my directory to that, and it will just look to me like a regular directory, okay, once it is mounted, okay. Again, what is the mounting operation? You have a raw device, you insert it into the device whatever, and then some control actions take place, and then you finally graft the file system that is sitting on that device onto the, that is attach it to at some point to the Unix file system, okay. And then from then onwards you can change directly to that place, and you can just do, you can navigate up and down the file system structures just like a regular directory on a regular system, okay. So And you notice that if you are having a camera, for example, the assumption is that the files are stored as in FAT32 form. Like everything is using FAT32, so that you can incorporate some intelligence in the camera itself, that is the FAT32 file system, and you can start using it, okay, the way a FAT32 system. If it's some other file system, then it's a big problem. Somebody has to make sure that that particular driver for that particular file system is there, okay, the device driver for that file system is there, okay. So what has happened is that people have assumed that FAT32 is a common denominator, everybody can assume that it's there, okay. Now that is independent of your accessing things at SCSI level. The file system is at one level. For example, SCSI only talks in terms of blocks, okay. It doesn't have the notion of directories, etc. But a file system has a notion of directories. It also has a notion that this, if there is a directory, I can talk about parent of the directory. That is, in some sense, I can have a tree-like structure, okay. A SCSI command on the other hand doesn't. SCSI protocol has no notions of a parent of a particular piece of information. It doesn't have this kind of information, okay. Basically, in some sense, directories are not there in SCSI, okay. So, what is the usefulness of file system? It basically allows you to name things and retrieve it using easily remembered names, okay. That is what a file system is doing, okay. It is certainly much more complicated than what I am saying right now, because when it comes to concurrency and caching and so many things, it is quite delicate. It is not easy to get, even making it, it is very difficult to get all these things working very well, okay. But in principle, what it is doing is we are assigning names to piece of information and be able to access it later, okay, in a directory, in a tree structured form, okay. So you can see the multiple levels at which you are operating. One is at the level of hardware, which basically senses the device. Second thing is the transfer information across the PC and the device, for example, that some kind of communication infrastructure is there. Then you need to be able to locate piece of information that at the block level, that is basically the SCSI command level. And if you want it to be even more intuitive, you want to access it at the level of files, then it's one more level, okay. So there are multiple levels at which you are operating. So I just picked up this picture from the USB specifications. The diagram that draws something similar to this. Well, let's see what is this. So there is a USB hardware here, and there is a host controller, okay, and then there is a serial bus which is connected to this, okay, and basically there is a device driver in the kernel. It has got a function abstraction of what it is doing. For example, this device driver is for, let us say, it assumes that there is a capability for accessing certain blocks, some named blocks, okay. That is what is assuming, okay. And this host controller, what is it doing? It is basically preparing for data to be transferred on the serial bus. It is noting when the transfer is complete. It also could, for example, be a DMA. It can do DMA access, okay. So all this part of it is here, okay. So there is also a device abstraction. Basically, you have a lot of interfaces. A good example is, suppose you have a camera. Sorry, let's take, instead of a camera, let's take a printer. A printer has the functionality of printing and also sometimes scanning, faxing, etc. Okay, there are various interfaces. Okay, so the question is which kind of interface you are referring to. Okay, all those things come into the picture here. Okay, so sometimes there is only one interface. That's simple, but sometimes you can have multiple interfaces, and you have to decide to choose which interface. Okay, for each interface, you might want to configure the device also in different ways. For example, the printer might require certain configurations, which is different from what is required for scanning. Okay, all that is handled here. Okay. So, in a sense your applications are somewhere here, they are accessing it through some file system, and then finally the file system accesses the device driver, and then that in turn goes through this part and then comes up this. Okay. In a sense there is a connection between the device driver is talking to the USB at a functional level, the host controller is talking to USB hardware at the electrical level or bit level. You can call it bit level, because nowadays I can even do the following. I have what is called a thin client, right, and I want to put the USB device on my thin client. The thin client is talking to a server somewhere else. I actually wanted to make the server pretend as if it is the USB is connected to the server, right. Somebody is going to do some faking out here. Instead of a serial bus which is happening at the electrical bit level, it might be happening at the bit level, but using the network. That also is possible. Okay. So in a sense you will see that there are different levels of abstraction in the system, and you can understand this whole thing only if you understand these levels. Okay. We will go a bit into more detail, some detail, further detail as we go along. Okay. So again, to repeat, what are the USB layers? The lowest layer concerns itself with aspects relating to serial transmission. The next upper layer handles USB protocol specific aspects. This is common to all USB devices. Okay. The next layer is function specific. For mass storage, this involves classic commands. Okay. So device like camera have another layer. This is the file system layer, as they should be able to store pictures taken without any outside help, because you don't need a PC for that. You should be able to do it itself. So it has also got. Okay. This you might call it the file system layer, and it might even have a camera, might even have some other higher level things, okay, on top of it. Okay. It might also be that you can attach legacy devices with USB support, right. We already talked about if you want to keep data alive for a century, it is not trivial. So what I want to do is I have a floppy now, I want to read it 100 years from now. What can I do? I want to emulate the legacy device, the device of 1990, I want to emulate in 2015, okay, but I want to use USB protocol for it. That is, I will somehow figure out a way of connecting that particular floppy device, floppy disk. I will electrically do something interesting, okay, so that it can be somehow fit into the, I can connect it to a USB, let us say type connection, USB type device, okay. Suppose I am able to do it, but still there is a piece of software that has to be there, right. So that has to be also emulated, okay. Now the USB master specification provides what is called a block interface, okay. What does it mean, a block interface? It means it is accessing things at the in units of blocks. It is not at a byte level, it is at a block level. Block level can be 4 kilobyte blocks, it can be 512 byte blocks, whatever, that is up to you, okay. So there is a block size and it is accessing it in only in terms of blocks, in units of blocks, okay. Because it is a block interface, you need to go through a protocol called mounting, okay. The mounting protocol essentially is a initialization step before you can access the block device, okay. Basically what you are doing is, you have the information on the USB device and you want to graft it, you want to connect it into the file system tree, okay, okay. That is what you are going to do. So once you do the mounting, that part of it is done. That is, you are able to take the file system that is sitting on the USB device and you are now able to attach it to your main computer system's file system, attaching it some particular place, so that all the files that are there on the device are now accessible from the machine, from the PC, and you can, as I mentioned before, you can change the directory to any place and you can walk up and down the file system tree, okay. So only the system that has mounted access. Again, the thing is, if you have mounted it, the party who has mounted it has exclusive control on it. Basically, the idea is that if our concurrent requests come in, there is a problem, right? Because if there are concurrent requests, one guy can leave this. You sometimes have to modify things. When you modify things, what happens is you might have to touch 3 different places before the operation is complete. Now, you might have done 2 things. Before you do a third one, somebody else comes and does something else. The system is in an inconsistent state. Okay, somebody else is able to watch, see things in a state before all the operations are complete. Okay, which can be a serious problem. Okay, so you want to avoid it. So if you want to, one way to do it is to mount it and therefore only allow one person. There are sometimes you need multiple parties to access it at the same time. Okay, so you might need another protocol for that. Okay, that is not standard. Okay, so for example, camera with USB storage, or even if you take one of these Android devices, you attach it to a USB port. It gives you 2 options, right? It says, do you want to think of me as a USB device, as a storage device, or as somebody else, right? If it is used as a USB storage device, then somebody has to program that particular Android device as if it is only a mass storage device, and that has to be done by the master, you might call it, the PC. Okay, then you can transfer in and out of the thing. Okay, so essentially you have to ensure that there are certain protocols by which you can access, multiple systems can access, right, at the same time, but you need some specific support for it. Okay. Now, you can also attach, some of you might have seen a SATA disk which has got a USB interface and attached to your laptop or a PC, right. So, the fact that certain types of commands are possible on the SATA disk, for example, something called, we will come to this later. For parallelism, you have something called NCQ, native command queuing. Okay, there are multiple requests to the SATA device can be queued up, and it can essentially allow you to do multiple things at the same time. Okay, it can queue things. Okay. Now, even if you have that support, does not mean that at the USB level you might have support for it. The SATA disk might have it, but may not be unless it is exported at the USB level also. Okay, that is something you have to keep in track. So, let us just quickly look at the Linux situation. So, basically what is happening is that in the Linux kind of system, some things are done on a system, right, something happens at hardware level, some things happens at the kernel level, the operating system level you might call it, something happens at the user level. Okay. Of course, operating system is both user level things and kernel level things, but the kernel thing is a protected subsystem, right, and user is the one where things are operating at as a process level, right, and the user is writing this code. Okay. Now, the USB device is here, there is a host controller, this itself is a device. So, there has to be another driver for the host controller itself. Okay. And then there is a USB core, which is basically the thing which does the protocol for USB devices. And then there are specific USB device drivers. For example, you might have the file system layer on top of this, or a block layer on top of it. It could also be a net layer, for example, if it is a dongle, right, for example, those kind of things, etc. Okay. Sometimes there are USB FS also available in some systems, by which you provide all this information, whatever has been figured out, right, through what is called a proc file system. In Linux, there is something called a /proc file system, and if you use essentially all that kernel information can be made available in a tree like structure, the proc file system, and anybody who has got the right permissions to look at the files can see it. Okay. And then because you can be writing your own code, because you got the information now about the device, what its characteristics are. Now you can write your own driver using information that has been gleaned out from through the proc file system. Of course, you might still need to be root. Okay, if you are not root, you will not be able to do anything useful. Okay, so you will be able to, because you have special privileges, even as a person has written user mode driver, root permissions are there on it. Therefore, you can use the information that is there at the /proc file system and be able to access the functionality of the USB device. Okay, so user mode drivers are possible, user applications are possible. Okay, that means user applications will directly use this part. For example, your, let us say, browser, for example, is using, it wants to upload some file from the USB device. So the file system is already attached, mounted. Therefore, the application using standard fread and all those things, it accesses it, and of course somebody is translating it into file system related calls, okay, fat file system calls, and then that in turn is going to USB device driver, and finally all the way up to USB device where the information is picked up. Okay, so there is a USB framework that is available in this kind of systems, in Linux kind of systems, and it's got multiple levels. Okay, I just want to mention that this is typical of any storage system. Okay, you will find that there is some real hardware. It could be a disk, it could be a flash device, tape, whatever it is. There is some hardware related things, some way to control those things, some protocol related things, because finally what's happening is that the devices are all the time changing, right. You will find that the tape of 1950s is not the same tape as of today. Okay, they will use some different types of technologies, and certain things what are feasible there may not be feasible there. So the thing is, the technologies are all the time changing, but if everything keeps changing all the time, then you get into a problem. So what you want to do is to abstract away certain things, so that certain core things do not change. Okay, and using that core, you are able to talk to even newer things that come up. Okay, so the USB core is basically one of those kind of things. It's a protocol level, protocol specific things. Okay, so that you can talk to, there is some specified set of operations that you can depend upon. Using that you can handle old devices as well as new devices. Okay, and any specific thing, okay, any specific thing, okay, for example storage, or it's a Wi-Fi, whatever it is, that is handled specifically through this. Okay, so specificity comes from here, generality comes from here, and the hardware related aspects come from here. Okay, so let us just try to understand what happens when I insert a USB stick into a system. Okay, first of all, the hardware senses and interrupts the CPU, right, because electrically it is sensed and you interrupt the CPU. Finally, you have to identify some agent. Okay, in the interrupt routine, basically interrupt routine does some basic things, and it identifies a kernel thread that is going to be initiated to handle the insertion. Okay, but basically what the interrupt routine does, all it does is it knows which port was there. For example, whether it was this port or this port. For example, USB can have multiple ports, right? It says that okay, it came from this side or from this side. Okay, so that has to be identified. Also the controller, okay, who is going to, there could be a hub there, it could whatever, you might have heard about USB hubs, right, there could be a hub there, or there could be multiple hubs also there, right, it has to be, you have to figure out who is going to control this. The speed and the PC address. Once upon a time, USBs were running at lower, let us say, speeds. Now we have USB 1.0, 2.0, 3.0, okay. Somebody has to know what the speed is, okay. In a sense, most of the designs are to some extent self-identifying. They will tell you what speed at which they can operate, okay. And also typically these devices have some memory, persistent memory, and that has got all the details about about what IO addresses it's comfortable with, okay, what are the PC addresses it should be mapped to, etc. Okay, some of the details are here. Okay, in a sense, the device itself gives information because it knows about itself, so it can tell the kernel, which has not seen this device before, what are its characteristics. Okay. So the interpreting only does some simple things first, okay, because interpreting by definition should not take too long. So only simple things are initially captured, and then the interrupt controller interrupt routine basically says that this kernel thread is going to do some work, and this guy is going to use the information I am giving it to him. The kernel thread gets scheduled sometime later and notes the PCI information, okay, that it's a USB mass storage device, whether it is this device, that device, whatever. Okay. And then the kernel thread, what does it do? It calls an user program. Okay. Typically, it's a user program. Why? Because there is so many different things you can do. Okay. USB is, you can just imagine how many types of USB devices are there. Okay. So you don't want to put all that functionality in the kernel because the kernel is already big. Okay. You don't want to put too many things in it. Okay. So for example, there is a program called /sbin hotplug. Okay. What is hotplug? The ability to insert things in and out without shutting down the system and restarting it. You can put it in on a live system. So there is something called hot plug where I can put the USB device hot and the system is running. Okay. And it basically gives you some control at the user level. When I mean user level, I don't mean at the person using the memory stick. I am talking about the level of the person who has configured a system so that this kind of thing can be easily used. Okay. So, and basically this is the policy is now at the user level, not at the kernel level. The kernel level means it is true for everybody. Okay. It is going to be valid for essentially for everybody. A user policy agent means that you might want to have your own specific kinds of approaches to how to handle the device. For example, it may be that you have an SBN hot plug and you are in a very sensitive system, no outside devices should be allowed. Okay. That guy immediately says get lost. Okay. I think some of you know that a lot of the problems about viruses that are spread is with somebody bringing in outside devices and attaching it to in critical installations, and oftentimes there is some automatic program that runs when insert a particular device like CD or USB, and that is basically user level policy in some sense. What should happen when I put in? Okay, and that can be good for most of us, but sometimes it can be bad. Viruses travel through this automatic route. Okay, so this program like SBN hot plug, what it does is it notices that the USB device with this, which port, what kind of controller, what kind of okay, what kind of a device it is, all that stuff is, what kind of a driver is going to be, has to be used to understand this device. Okay, all those things are there. Okay, so it figures out what resources are needed. Okay, it configures the device, it helps to load the driver. For example, if it's a mass storage device, then you might want to do the it's going to load the driver and using configuration files. Okay. So, for example, what is configure the device? It may be that I have to let the device interrupt at a particular interrupt line. Okay. Or if I want to talk to the device, I might have to give it some kernel memory so that it can prepare certain command strings. Okay. For example, when you have a SCSI device, you need to have something called as SCSI control block, which is used to talk to the device. Okay. And vice versa, there is some, if you want the device to send back information, it needs to know what kernel memory to use, okay, because the memory that is being given is not within the device, that is going to be used, sorry, within the device, okay. It is something which it has to pick it up from the host kernel memory, okay. So, given these things, you have to do some configuration, okay. So, once the device and driver have been initialized, then basically you can mount the system and display it to the user. Like for example, when you on a regular system, when you update, when you insert the device, you get some kind of a graphical user interface you get, right, saying what do you want to do with it, right, those kind of things, all these things can be done, okay. So, let us just look a bit more into some more detail. Even if there is no driver for USB device, you can still detect the USB device, okay, because this is part of the USB protocol specs, okay. The driver actually does the specific aspect of the device, whether it is mass storage or it is wireless or whatever it is, there is a camera, all those things, okay. That part of it is done by the device specific part of it, but up till the generic part it is done by the kernel, because if it is a Linux kernel which has support for USB devices, the generic part will always be there. That means that, this part will always be there, okay. Because it is always there, it can get to the point where it can do whatever generically it can do, okay. This is required for specificity, okay. So, hardware direction by USB host controller, okay, and basically the host controller driver gets low level physical information and converts it into higher level USB protocol specific information, okay. And this information is populated into generic USB core layer, okay, the USB core driver, okay. So, in a sense the kernel knows about the USB device now. It may not know exactly how to use it, that is a different story, but it knows what device has been inserted, okay. Then depending on the availability of other drivers, interface and applications, depends on the specific line of information, it gives user space a view of the detected devices, okay. Now, this is what is the thing that gives you the thing which is user friendly part of it. Up to this point, the kernel knows about it, but beyond that it can't do anything because it does not know what to do with it. You need to give additional piece of information, the specific driver for accessing that particular USB device. In our case, mass storage, you need to have a USB mass storage device driver. And USB mass storage device driver assumes that it's a SCSI device and it knows that it has to send and receive. I send SCSI commands and it gets back responses, okay. So, again there are a lot of interesting things about this thing. Basically, there are multiple configurations for a USB device, okay. So, I can have multiple interfaces, I already talked about this, okay. So, for example, you have multi-function devices, USB printer for example, it has got printing, scanning and faxing, okay. So, that is why there are multiple device drivers. For example, a camera will have, the printer will have multiple device driver. It is not that one device driver actually handles all three functionalities. There will be a device driver for each functionality, okay, and typically in this kind of situations, USB printer kind of situations, okay. So, something interesting about USB devices is that one USB device may have multiple device drivers and different device interfaces may have the same driver also, okay, that also is possible, okay, both these are possible. So, we will just quickly look at some aspects relating to how Linux actually handles it. I think if you look at the Linux kernel, you will find that there are some header files in a particular place, and that is how this is the notation used, okay. Usually means it is /user include etc. If you look in there, you have this functionality called USB register and USB deregister. So, what is this USB register doing? It gives information about name of driver, what probe disconnect function to use, okay. So, basically what we are saying is, there is a, you want to say, okay, basically what is happening is that I want to, I have detected the device, okay. Once that device has been detected, you have to somehow give some additional information about which driver is going to act on it, use it. For example, all that has happened is, I have to say which driver is going to be used, because I am at this point here. I want to say what driver is going to be used on it, okay. So that is what is going on at this point, okay. So what I am going to do is, I am going to say, now that you know that this device exists, please use this particular, let us say, function, this probe function, to know that everything is okay, that this is actually the function that has to be used for accessing this device, okay. And the way I do it is by, the name of the driver also I give it, okay. So once I am done with the use of this particular device, I can do USB deregister, okay. So normally it turns out that there is a similarity you might see. You see that file systems usually register with something called the VFS layer. Here the USB devices is due to USB core, okay. Now that the USB core has been told that this is the driver name, the driver itself has some functionality. One of them is probe and disconnect, okay. So the USB core then uses the name of the driver. In the driver it has got two, let us say I said two functions, probe and disconnect, of course it has got other functions. Then the USB core calls that probe function and convinces itself that it is the right function, right functionality. That is, somebody is giving information about how I should be accessed, the kernel in turn really checks again, it is just a way of checking, okay. And then you can do some specific data transfer functions, okay. So you can send control messages, you can send interrupt messages. For example, I can cancel a request. Suppose I am doing some things, I want to cancel it, okay. It is possible in some cases to say, please stop that copy that is going on, okay. That I can also, that is interrupt message, okay. And these are basically the things which tell you how to use, how to send bulk data, okay, these ones, okay. The way to do all these things is, basically you have something called a USB request block, and because the devices are slow, it usually uses asynchronous IO, okay. And basically what happens is, you send SCSI commands to the USB mass storage devices, okay. The exact specifics are as follows, okay. So first of all, what happens is that when the driver has data to send to USB device, you have to allocate what is called URB, okay. What is URB? URB again is the USB request block, okay, some piece of kernel memory that is allocated, and you also allocate a DMA buffer, okay, because what is the DMA buffer? The DMA buffer is basically a way of programming the hardware system so that they can transfer data efficiently, okay. So they will have to have something like counters, etc., so that it keeps track of how many bytes have been transferred, all those kind of things, okay. So you also want to create a DMA buffer where from you are actually transferring things, and you also want to program the DMA engine itself, okay. So the data that has to be sent, for example, if we are talking about the write, you copy the user data into DMA buffer. So the user data could be coming from user space, and then it has to be copied into DMA buffer. That means that again this is a kernel function which actually has to be careful that user is not giving you some thing which can create some security problems, okay. It has to be mapped, it has to be a legitimate piece of in the it's not an illegal address, for example. Okay. All those things are checked by the kernel and then it's copied into DMA buffer. Okay. Now, once we have the allocation for the URB and we have the DMA buffer where the data that has to be transferred is already copied into, then you can initialize what has been the URB allocation. Okay. You initialize it and then you send it to the USB core. The URB, when it is initialized, you also send it what kind of functions to use for doing any bulk transfers if possible. Okay. And then also it gives you a callback, that is, once the function is completed, who should be called. Okay. So, now once it is done, the URB is transferred to the USB device. Okay. Now, this can succeed, this can also fail, for whatever reasons. Okay. In spite of whatever happens, the URB callback is done, so that to complete whatever, either because it completed successfully completed it, therefore you might have to do some cleanup, or if something bad happens also you might want to do cleanup, that also. Okay. So, in a sense, what is happening is that if you think about this, if you look at this particular framework, right, what is going on here? You want to send some, you want to write to something. So, there is a application out here which wants to write something. What is it doing? It has got a user buffer. That user buffer has to be copied into kernel first. Okay. And that is going to be done by the file system there. Okay. Or you can be doing it directly from user mode drivers. Okay. If you have a user mode driver, you will not go to the file system layer, you might actually directly come through this. Okay. So, that is the reason why we were talking about copying it from user space to kernel space. Normally, it will be done by the file system, because normally what is the situation? I have a FAT file system, FAT32 file system, and the user level actually uses a C library, and C library has something called F read and F write. F write actually takes it from your user buffer and copies it into the buffer that is used by the library. That in turn is copied into the file system. It also copies it into a kernel memory there. Okay. And then the USB device driver now knows that it is already in the kernel space, may not need to actually copy it into another place. Okay. It may be necessary in case the DMA buffers need to be in a particular place. Sometimes you will find that in some Linux systems, the DMA can only happen if in the lower 24-bit physical address space of the memory. There are some restrictions of that kind. So, then you might want to copy it into the lower lower 24-bit physical address space. Okay. Those kind of things are all done by various subsystems out here. Okay. Finally, it is in the DMA buffer, and then you are now asking it to, you create a URB now, because now you are somewhere at this point. You create a request buffer which has all the data, and you are asking it to use a specific type of command. For example, I mentioned the send block, right? Send bulk type, sorry. Okay. Use this particular function, saying that use this as a way to transfer information. Okay. And this might, because I am using URBs, this might actually do the asynchronous IO part of it. Okay. And then the host controller, they might do some additional things. For example, it may be that whatever information I have to send has to be chopped up into pieces and sent. It may be that this guy can understand only some different units. Why is that? For example, if you take your regular USB memory stick, it has its own notion of what is called read size, write size and erase size. Okay. So, if you ask it to write a small portion, right, if it has to reuse that part, somebody has to erase the whole thing, then write that part, right. So, it may be that some of those kind of things are happening at this level. It could be that you are writing in terms of units of what is the size of a fast file system block size. It can be 4 kilobytes, it could be I think with different types of fat systems you have different block sizes, right. The clusters and various things are different, right. So, because there are difference, the unit at which you are writing is different for different file systems. That may not be the same as what is there in the USB device. So, somebody has to do what we called last time segmentation and reassembly, and that is happening at this point. Okay. And once that happens, the data is sent out for writing, and once it is completed, this host controller, USB host controller will get a notification from the device saying it is complete. It will send an interrupt. The USB host controller actually is notified. Okay. It typically host controller will handle all the interrupts for some time till it decides to interrupt the CPU. Okay. Once it decides to interrupt the CPU, then you know that the operation that you sent out earlier is complete, and then in turn what happens is that callback function that was registered, right, will be called, so that the any cleanup activities whatever has to be done can be initiated. Okay. And so, this is roughly the model of how transfers take place, and we have not really discussed other things like how concurrent operations can take place, etc., but there are some details that also have to be further looked into. Okay. So, what is interesting for us is basically how many things are involved before you can get a USB to work. Okay. You have a user application which actually shows you the GUI saying what do you want to do with this thing. Do you want to think of it as a mass storage device, or do you want to use it as some other type of device, right, like I mentioned about Android device, right, it gives you an option. Okay. All those things are user level applications, and then there is a FAT32 file system typically for USB devices, that what applications are using to write. Okay. And there are other pieces of things that are already there which have to all work together before you can get any data in and out of the system. Okay. So, basically many subsystems have to work together, and you will find that this kind of structure is there in whether you look at small systems or big systems. For example, suppose you take a very big, huge, massive storage system, right. First of all, I need to know where to write to, right, because I need to know that such thing exists. First of all, somebody has to tell me that this device exists. It could be a artificially created one, that is, it is actually composed of 10 1 terabyte disks, and somebody is making it look as though it is a 10 terabyte disk. Okay. And I need to know that somebody is giving me that there is a virtual 10 terabyte device out there. So, some kind of discovery, and so some need to know figure out where the device is, what is the name I give it to it, so that I can start incorporating it into my system, so that I can say that this exists, now I can start using it. Okay. So, there is some aspect of device discovery. There is an aspect about how you can take the information there which has to be recognized as a file system, for example. Somebody has to mount it. Once it is mounted, then the user application has to know where it is mounted. Okay. So, and then once it is mounted, then you have some notions about in what units of granularity you want to send information. Okay. And that might be different from what these devices are comfortable with. Somebody has to do some translations, okay. All those things are required, okay. You will find that this is true for almost any large scale system, okay. You will find that there are a lot of multiple aspects that have to be handled, different interfaces will be there which will be, different layers will be there which will handle different things. We have not really talked about things like encryption, decryption, etc. It could be possible that you want to encrypt things here itself, okay, because nowadays you have so many USBs, you can leave it here and there and forget it and somebody can look at some sensitive information. So, you might want to have encryption somewhere, okay. Now, where should the encryption be? Should be at the user level or should be at this level, okay. Ideally, it should be somewhere at this level, so that, but then there is, I guess, as I talked to you last time, there is device the key management is an issue, okay. So, there are lots of issues of this kind that have to be all looked into, and a system perspective is important. Okay, we will continue with next time on some other examples.